Hey, welcome back. This is Mr. Elmhorst. Let's take a look at our science lesson. We're moving into our new unit. We're going to start motion, speed, and velocity. So when we're talking about the change in an object's position over time, we're mainly just focusing on the change in the object's position, which means we have motion. Something is moving. So the motion can be measured. We have measured in direction, displacement, distance, speed, and velocity. So this is going to be motion. We're going to measure it in different ways. So the change in position of an object relative to a starting reference point. Now, just for a easy, quick visual. So let's say we have right here, and then we loop around, go around, we're going all over the place. And then we stop over here. Now, distance would be the line looping around, going everywhere. Now, this next vocab word is going to be displacement. So, displacement is after all the movement and everything, what is the actual distance between the starting point and the ending point? Okay, so that is going to be called displacement. So, it's going to be the distance from the starting point to the ending point after a whole bunch of motion has taken place. Now, if it is a direct line from wherever was the starting point to the ending point, well, that is simply going to be just the distance. So if there's no extra movement or anything, it's just a straight line, that is going to be the distance, the total length of a path taken between a starting point and an ending point. So we have motion, and if there's a lot of motion, we have displacement, and then that's the distance with a lot of motion going on, or we just have straight distance. And then we get to the next definition here. If we're talking about how fast something is going, and that's from point to point, that is going to be the speed. So that is direct distance over time. So the speed is measured as a ratio of distance, not displacement, but just distance. And that's going to be a ratio that is being compared to time. Distance over time as a direct ratio. So ratios, we should have been familiar with that as far as sixth grade math. So the comparison of distance over time tells you how fast something is going. All right, so looking at the first example here, if we have an average speed of an object that's traveling 220 kilometers in 4 hours, so the distance is 220 kilometers, and that is being compared to in the ratio that is happening over 4 hours. So this is a rate, but it's also speed as a comparison where the distance is changing compared to time. Now, this should look familiar as far as sixth grade math, where we have the ratio 220 compared to 4 hours, and then we can set this up and try to do it in a more simplified ratio where we compare it to 1 hour. So it's going 220 kilometers in 4 hours. And if we do some simple math here, if we divide by 4 and divide by 4, 4 hours divided by 4 will give us 1 hour. 200 kilometers will give us 200 kilometers divided by 4 will give us 50. And 20 kilometers divided by 4 will give us 5. So how fast is this speed? And when it's being compared to 1 hour, well, it is traveling at a speed of 55 kilometers per hour. Okay. Now, that is a ratio within a word problem. We can also take a look at a graph. So we have time and meters. So in this particular relationship here, we have 100 meters, and that is over 1, 2, 3, 4, 5 seconds. So at this particular point in the graph, the speed is 100 divided by 5, so that would be 20 meters per second. We can also take a look over here and see what is the speed, and it looks like it's 170. So 100, so 10, 20, 30, 40, 50, 60, 70. So point C, we have 170 meters, and that is at 20 seconds. So it looks like we're going at a fast rate, a fast speed, and it's going 20 meters a second, and then it looks like it slows down. And then we're not going as far in meters as we are with seconds. So we have 170 divided by 20. If we simplify that rate, divide by 10, divide by 10, 17 divided by 2. So it looks like that's probably going to be 8.5 meters per 1 second. So we have a given speed of the meters per second, and then that will change as we move through the graph, and we can identify what is the given speed at each point by putting distance over time as a ratio. And the last one we're going to take a look at is not just a speed, but also a direction. So if we have speed and direction, that is going to be called velocity. So velocity is the speed of an object in a particular direction. So we can call it going north, south, east, west. But if we have a direction of where we are going with the speed, then we're going to call that velocity. Now, the velocity, we are not going to measure that as distance over time. So this other thing called displacement is the change in position and relative to the starting point. So velocity, we can measure after we're moving all over the place, we can measure the starting point and the ending point, and that's going to be displacement over time. So displacement over time will give us the velocity of whatever direction we're going or whatever units that we're talking about. Okay, so speed is distance over time. Velocity is going to be displacement over time. All right, thanks for joining me with the science lesson where we looked at motion, speed, and velocity. So you're going to glue this into your journal on the next open page. Do not skip a page. Go side to side or front to back.